That's right.
I think the units are right.
Yeah, Dr. Kuehn, can you come check this for us?
Yeah.
See if this is right.
Oh man.
Can you guys come check our word? We can't figure out what we did wrong. There it is. Okay.
I don't know what's going on, but if anyone finds this, please tell my mother that I loved her. And that I was a good student. Oh God.
Breaking news! A new outbreak has started at the University of Northern Colorado. Reportedly, students are turning into beloved Professor Charles Kuehn. Here is live footage from the scene of the outbreak.
So, what is dark matter?
Well, we know it doesn't interact electromagnetically, but it does interact gravitationally.
We all obviously know that gravity bends light.
Well, it can't be neutrinos, because dark matter must be non-relativistic. But it could be machos.
Ah, yes. And who remembers what machos are? And no, I am not talking about nachos.
Well, those would be the massive compact halo objects, and there are a few candidates for them.
They could be brown dwarfs, cool white dwarfs, large planets, or even black holes.
Oh, very good. I know nothing about machos. They're named really stupidly.
Great point, Keelan. Why? Why did they do machos? If it's massive, compact halo objects, they could easily just do MCHOs and just pronounce it machos. And then you don't have the A here. And if you're gonna write it like that, you should write it like machos because the A is part of the massive.
Approximately 10 hours later.
Make it make sense. Please make it make sense.
A is spelled capitalized.
Yeah, because they're not even thinking. It's not creative. It isn't. Dr. Kuehn? No.
Go Buckeyes, go Buckeyes.
Objects.
Ah, shit. Okay. So, why do we even care about machos?
Well, we can use machos for gravitational lensing.
Two nearby galaxies.
Which is...
Well, gravitational lensing is going to be when light from a distant galaxy is bent by a massive object and focused onto the observer. For anyone who has taken optics out there, it basically acts as a lens.
Hence the gravitational lensing.
And with that information, we can calculate how bent the light is using that formula on the board.
Might want to check that.
The R should be a B.
Great catch, Keelan.
Alright, let's do an example problem. And let's fix the equation. So, let's find the maximum deflection for a photon that's grazing the surface of Venus. The mass of Venus is 4.87 times 10 to the 24 kilograms. And the radius is 6,052 kilometers. Okay.
That's there. Yes.
Yep.
Um,
Don't forget to use the mass of Venus, not the mass of the sun. Yep, that's good.
Alright, for the sake of time, let's do it on the board. Okay. So G, gravitational constant. The M you plugged in was for Venus. Speed of light. And then some of you keep forgetting how units work. Make sure this is in meters and not kilometers. And then we should get at 2.4 times 10 to the negative 9 radians.
So, now that we've worked out that, what we actually see is not the star, but rather a ring of light.
And this ring is highly dependent upon the alignment of the observer with the macho and our light source.
If the macho is even slightly out of alignment, we'll actually see a crescent and not the full circle. However, we can calculate the radius of that shape using the equation behind us.
Let's do an example problem. So, to calculate this, we've got this formula here. Now, who can tell us what this means?
The gravitational constant.
Good. And this one?
Mass of our macho.
Alrighty. And C?
I love the speed of light.
Alrighty. And D?
The distance to the observed object.
Good. Alrighty. And what about this X over here?
Distance to the macho.
Perfect. Alrighty. Now, we're going to go ahead and calculate this in this hypothetical scenario. We've got X is about 0.5. Our mass is going to be about 0.1 mass of the sun. And our distance to the Large Magellanic Cloud is about 50 kilo/6. Alrighty. And what did we all get?
6.2 times 10 to the negative 10 radians.
Good, good. Alright.
So, can we actually resolve that with one of our telescopes?
No.
But what we can do is look at the flux.
And anytime we see a peak in the flux of a distant star, we know that's been gravitationally lensed by a macho that's moved in between us and the star we're observing.
Good point. So, do we have any more questions about gravitational lensing?
Any weekend plans, Kuehn?
Just some officiating over in Julesburg. Actually hoping to get some nachos. Yeah.
Along the way, yeah.
Not machos?
Not machos, no. Entirely different.
How about them Buckeyes, though?
Guys, doing great.
Doing really
Don't
well
worry,
this season. And now, back to Kuehn with the space weather.
We'll start off our week with the cosmic microwave background at a 2.7 Kelvin. Heading into Thanksgiving, it'll be still 2.7 Kelvin. And we'll finish off the week with a strong 2.7 Kelvin. Back to you in the studio.
Thanks, Kuehn. This is Kuehn signing off.